It's not only the most exciting project in the history of humanity, it's the most exciting project in the history of the planet. I read that in the newspaper back in 2013. If you had the question, how long did it take you to decide to move to Mars on a one-way trip? 0, 0, 0. It was absolutely instant. I think the people that go, it needs to be 100% certain that this kind of adventure is exactly how you would enjoy living the rest of your life. I can't imagine a bigger opportunity than being able to explore a new planet for the very first time and of course share this adventure with Earth. So as a researcher from physics, I love asking big questions, and I believe that's not limited to researchers. That's what humans do. Studying life from a physics point of view, that was what I was doing in quantum biology. Quantum biology just means studying life on very small scales. Every plant that has chlorophyll is photosynthesizing. Bacteria, algae, all of these living creatures use sunlight to power themselves. And did you know that we haven't even begun to understand exactly how that process works? I know you learn about photosynthesis at school, but trust me, that's the tip of the iceberg. We were trying to understand photon by photon, right, particles of light, how they get absorbed by the chlorophyll molecules and how they get turned into power with 100% efficiency. And they actually use quantum physics to reach this high efficiency. So who's heard of the quantum computer? We don't have it yet, but people are trying hard to build a quantum computer. So far, we haven't managed to achieve it. Guess what? Those leaves over there are using quantum coherence to live. So there's a wealth of information in biology, things that are really performing miracles every moment of the day, that we're still trying to understand exactly how they work. So that's one part about trying to understand life. Another part is something we've all done. Maybe not all of you have studied quantum biology. Maybe some of you will. But for sure, all of us have sat outside at night and looked at the sky and wondered, is there another intelligent creature sitting on a rock somewhere looking back at Earth? Are there other living things on other planets? Are we alone? Where did we come from? How did life emerge on this planet? Like, where are we going? What's going to happen to humans in the future? These are all questions we've all asked, right? This is to wonder about what life is. These are the kinds of questions that lead us to explore. All living systems on Earth have DNA. Every single one we've ever found that we consider living, it's crawling, it's moving, it's flying, it's alive, it has DNA. And this is great because that means we're all one family. It's important to remember that. Life on Earth is all one connected family, from bacteria to elephants to humans. We all have significant parts of our DNA in common, which says that we're all a family. We're an Earth life family. But if we're trying to understand what life is, that means we only have a single data point, Earth life. If we want to understand what life is in general, we need to find more information. You know what it's like trying to plot a graph when you only have one point. It's impossible, right? You don't know where the line's going to go to next. That's kind of what it's like to have a single data point. In trying to understand whether life exists on other planets, what life is, can it emerge in an environment like the environment on Mars, we start to look to space. We start to look further and say, well, fine, we've investigated Earth life. Is there life out there? So who here believes in aliens? Extraterrestrials? Good, I'm one of them. The chief scientist of NASA, Dr. Ellen Stofan, she believes in aliens. She believes we will in fact find evidence for life off of Earth in the next 10 years. So this is no longer a controversial point. So we haven't yet found evidence of life out there, but we have found amino acids. What are amino acids? The building blocks of proteins. All life has protein, therefore all life has amino acids. So it's interesting that we find amino acids floating around in space. That's probably the closest we've got to actually finding life, is finding some of the building blocks of life. And excitingly, with respect to looking for these kind of building blocks of life in space, did you know that we are currently building the world's largest radio telescope? So South Africa's got the main part of it, the Square Kilometre Array Radio Telescope. 7 other African countries have single dishes, and also in Australia and New Zealand we have some dishes. This is the biggest science experiment that humans have ever built. So you can see how big it is. It almost extends over most of the planet, because all of these antennae work together to form a picture with more resolution than ever before of space. Different galaxies, new galaxies. We've already found a new galaxy with the preliminary dishes that are already up in South Africa. And we look forward to potentially finding life itself. Because life is pretty tricky to look for. You've got to have a really highly resolved telescope, a really big, a really expensive one, and that's exactly what we're building. So what do data scientists do? They analyze data. And why has that got anything to do with the radio telescope? Well, the radio telescope will generate more data than humans have ever generated. This will be the Square Kilometre Array Radio Telescope, will be 160 terabytes. So how do you imagine a terabyte? I imagine those, hard drives. 160 of those every second. That's how much data will be coming from pictures of the sky, basically. So if you're interested in astronomy, fantastic opportunity. We are, as Africa, home to the biggest radio telescope. If you're interested in data science, analyzing data, acquiring data, storing data, being an engineer who builds data centers, all of this kind of stuff is going to be absolutely necessary in South Africa and the rest of Africa going forward. So great opportunity to participate in discovering new galaxies or maybe even life itself. So I think you've seen how trying to understand life, we study Earth life. We try to look beyond Earth to see if there's life out there, and that leads us to start exploring space. So arguably, some of the earliest ways that we explored space would be like my friends who were in Botswana 2 weeks ago, who saw rocks coming in from the sky, burning up and falling to the ground on Earth. Who's ever seen a meteorite hit the planet? It doesn't happen often that something is big enough to come through the atmosphere and be seen, but shooting stars, for example, are pieces of debris entering Earth's atmosphere. So stuff's coming in all the time. And early humans were actually touching space when they would go and pick up one of these rocks and say, where did this come from? The sky? Indeed, it came from space. And this is actually my own personal meteorite. It was a gift from a friend, Professor Francis Thackeray, and it's just a small piece. If I brought it, you'd probably be disappointed because it's just a piece of the bigger rock. Because by buying these pieces, you fund the research on the big rock. What kind of research do they do on the big rock? Well, first of all, how do we know it's from Mars? Well, Mars is already orange color, right? Because it's got a lot of iron oxide. We find exactly that kind of composition in the rock, plus a lot of other complex isotope ratio investigations. What else do we find? Air bubbles inside the rock. These air bubbles don't have 72% oxygen. They don't correspond to an Earth air. So what we do find is 96% carbon dioxide, 2% argon, 2% nitrogen. This is exactly what we know the Martian atmosphere to be. This meteorite traveled 200 million kilometers through space to land on the African continent in Libya. So after we were walking around as early humans, randomly picking up rocks and wondering where they came from, we started to develop technology. And this is my favorite piece of technology besides the internet. Okay, maybe they're both my favorite pieces of technology, is the Curiosity Rover. And we're so proud of this little rover. Well, it's about the size of a car, because of its discoveries and its contribution to our understanding of what's on Mars. So just this week, it's been announced that it's found very interesting organic compounds. So organic compounds are the things that contain carbon. We're not saying it's life, but we're saying this could be a place where life could have survived. We're saying this could be the remnants of life, or this could be the food that some life is using, which is still living on Mars. We're not sure. Also, methane has been emitted. And as far as we know, where there's methane, there's life. Living things emit methane. We emit methane. Cows emit methane. Other kinds of biological microbes or whatever emit methane. So this could be that life is living under the surface of Mars right now, and we just haven't found it yet. And if you're interested in that, wait until November, because at the moment while we sit here, a lot of crazy things are going on. One, the Curiosity rover is moving around in Gale Crater, collecting samples and sending photos on Twitter back to Earth and through NASA, not only on Twitter. While we sit here, there's a craft called InSight, which is a NASA shuttle, which is on its way to Mars right now. How long does it take to get to Mars? Around 8 months. It will arrive in November. It will land on the surface of Mars and start to dig where the Curiosity rover has been to see if that methane, if those complex organic compounds are not the result of something actually living under the surface of Mars right now. So I'm not talking about, I don't know, some large creature that's dug itself a hole and lives under the ground. No, we really don't expect that. We expect maybe microbes, maybe algae, maybe some kind of small microorganisms that we haven't been able to see yet that may be actually alive right now under the surface of Mars. That's the current activity on Mars. It's all robotic, maybe some life, some local life, we're not sure. But we've never sent humans to Mars. We plan this for the next 10 to 20 years to have humans establishing the first off-Earth settlement on the planet Mars. Did you know that you guys are going to be paying for the mission? No, really. So coming soon to a screen near you, that means that we're going to be broadcasting a documentary series on YouTube, probably. We haven't decided on a channel, but probably YouTube. And every time you click, we get money. We'll be broadcasting the selection of the 24, the training of the 24, the application of the next 100 or the next 200,000, because this is a continuous process. If you're thinking, oh, why am I not old enough to volunteer yet? Don't worry. There'll be subsequent rounds for applying to get there. And all of this will be documented and displayed on YouTube for everyone to watch. And I think even if you're a skeptic, I think this is something interesting. And maybe 7 billion or 8 billion in the next 10 years may be watching, generating the revenue needed to send more and more people to the planet Mars. Not everybody. We're not proposing that everyone needs to leave Earth. Earth is always going to be a more beautiful place to live. But what we are proposing is that space could open up for many more people. So not many of us know astronauts. Okay, I've met a few of them at events, space events. Why is that? Well, that's because only 550 people have ever been to space. That's a small number. So we can't really consider ourselves good at going to space when we do it so rarely. Why is it so difficult to get to space? Because it's difficult to leave Earth's gravitational field, and it's expensive to do that. That's the reason. So we'll talk a bit about how we're going to make the technology cheaper in a moment. But first, who are these 100 people who are in the finalists? Well, you had to be over 18 and speak English to apply, so I guess you guys can wait for a few more years before you get on the website. But you can actually join as a supporter and get monthly update emails in the meantime at the Community Mars One website. So these 100 people are not completely crazy, maybe a little bit, but mostly highly skilled individuals who see a contribution that they could make to doing something that's really difficult, maybe the most difficult thing we've ever done. So, as you can imagine, some of them are doctors, right? Absolutely essential would be to bring doctors with. We've got commercial astronauts who are already training as astronauts. We have engineers, of course, people who love to fix things, build things, create things. And these will be absolutely crucial people to keep us alive, because if the ventilation system breaks, the Martian atmosphere is 96% carbon dioxide. What happens when you breathe carbon dioxide? You faint. And then you die of cold if you're on Mars, because it's negative 50 degrees Celsius. So you can't survive for too long in that very cold temperature. So being able to keep the ventilation system working, crucial. Being able to keep the heating working, crucial. And these are all systems that will be maintained and repaired by the engineers. Of course, the engineers would also be aeronautical engineers, helping us with actually getting there, all sorts of skills needed from the engineering side of things. Then we're also researchers, so people studying planets. How amazing to study a planet from a planet. Like Mars researchers are now finally going to be able to live there and then do studies on Mars. We can study the history of the solar system by looking at 2 planets instead of 1. We can do climate studies. So did you know that Mars once had oceans? What happened to Mars's oceans? Can the same thing happen to our oceans? What kind of event can cause your oceans to disappear? These are important questions in terms of climate change that we'll also be investigating from Mars. People like me will be, out on the rover every day, picking up rocks, looking for fossilized evidence, digging holes, taking samples, taking them back to the lab to try and understand whether life ever existed there. All sorts of research activities will be going on. Also, the effect of living on Mars on the human body. So we'll be doing all sorts of tests on ourselves every day to see how someone responds to living on a different planet. The gravity on Mars is 38% of the gravity on Earth, so like 1/3. So who of you can pick up your friend? On Mars, you'll be able to pick up 3 of your friends. Who can jump this high? On Mars, you'll be able to jump this high. That's going to be probably the funnest part about living on Mars, is having less gravity than Earth. And imagine the first Olympics on Mars. I think we'll set new records in almost every category. But we've got comedians, we've got musicians, we've got all sorts of a range of people, most of them with a technical background and with a lot of hobbies that are also going to be useful in living on Mars. I mean, we're going to need music, we're going to need entertainment, so we need some fun people as well, and of course the technical skills. So I think I've explained my perspective of wanting to go to Mars, which is to do research, to maybe find evidence that life existed or still exists on Mars. But there's another reason why I think it's going to be really important for humans to appreciate Earth. And maybe we have to go as far as Mars before people actually realize what kind of a beautiful planet we live on. Maybe we have to prove how difficult it is, but that it's possible to live on the surface of Mars and show just how desolate and hostile and desert-like the conditions are there for people to start appreciating what we have here on Earth, because we take life for granted. We don't treat life with enough respect. Life is a mysterious phenomenon, as I've said, and we need to treat other living systems, whether they're animals, plants, or especially other humans, with more respect than we currently do. Another problem we have on Earth is resource management. That just means we need to share our water, our food more equally amongst our people, because the inequality that we see is also not a good thing. It is not sustainable. It's part of having respect for life, right? That everybody should have access to enough healthy food, clean water, clean air. And this sounds like something obvious, but in fact many people today live without what we would consider a normal level of food, water, etc. So living on Mars will teach us to manage our resources better. Again, I'm not saying everyone needs to go to Mars. In fact, I'd prefer it if most of you stayed here to take care of the home planet Earth. So if we can survive on Mars, we're going to be recycling everything. We're going to be 3D printing everything. Every drop of water is going to be recycled or used in a different way. There won't be such a thing as rubbish or waste on the surface of Mars. Why? Because rubbish or waste is just another resource that we should be using. We should be recycling. We shouldn't be throwing anything away. We live on a finite-sized planet. The only thing coming in is sunlight. Everything else is what we have. There's not going to be any more of it. We need to start having more respect for the life on Earth and also the resources on Earth. And maybe people will finally wake up and shift their perspective when we demonstrate what it is to live on a very hostile planet like Mars. So how will we live there? And I think you're going to see that these systems, these technologies that we use on Mars are also necessary on Earth. So first of all, solar power. We all know that that's the future, but yet we're very slow to start driving electric cars. We're very slow to install solar panels and stop burning coal. We're very slow to change. On Mars, we're going to be doing this from day one. So all of the research teams on Earth are going to be trying to make the thinnest, lightest, most efficient solar panels possible. These will be useful on Earth, of course, but for Mars, they will be the only thing standing between us and death, because we need to heat the living unit, we need to create the air, we need to do all of those things. So we'll bring along solar panels. The thinner, the lighter, the better. We don't want to have to lift too much stuff off Earth. And because of the Curiosity rover, it's measured how much sunlight there is on Mars, so we know exactly how many square meters we need to absorb that sunlight energy and turn it into power for our settlement. Water, very basic things now. Energy, water. Where will we get water from? And I think on Earth, we're realizing that fresh water is a scarce resource, in fact. Seawater's everywhere. But fresh water is a scarce resource. We need to do more to recycle it, to save it, and probably to desalinate in the future, to extract fresh water from the ocean. As we get to 10 billion people, there's not going to be enough left. So on Mars, we'll be doing something similar in that we'll be taking ice crystals out of the sand, removing the salts and other things that are in them. We'd be heating these ice crystals to melt it first, then removing the salts, then storing it in tanks. We'd have to keep the tanks warm because it's -50. If you just left your Jojo outside the settlement, you'd find a big ice cube when you wake up in the morning. So we'll heat that water to keep it liquid and have regular running water as we do on Earth. 2% of the sand, the Curiosity rover has told us, is actually H2O ice crystals. Plants die on the surface of Mars. It's too cold, the pressure is too low. So we'll have to grow all of our food inside. And this is the future of agriculture on Earth, in my opinion. A lot of people are moving to cities, urbanization. And how are we going to feed all of these people? Because as we know, agriculture sits outside the city. We've got to then transport it into the city. This is one way of using urban spaces in cities to grow food in cities, to keep it fresh, because there's no delivery time. Also, you don't use pesticides because it's inside. There are no pests. And this is the way we're going to grow food on Mars, taking seeds from Earth, of course. That's the one thing you do not want to forget when you're on the way to Mars, the seeds. That's important. You can forget your toothbrush because we can 3D print you a new one, but if you forget the seeds, that's really the end. So the water we can get from Mars, the oxygen, you might ask, where does that come from? Take a guess. If you have H2O, you already have oxygen, right? So we'll actually extract oxygen from the H2O. So that water molecule, very critical. And you might say, what are you going to do with the leftover hydrogen? Because I said nothing's wasted on Mars, right? Well, conveniently, hydrogen, you can make rocket fuel from hydrogen. So just from that H2O molecule, we know how important it is for life, but check how important it is on Mars. The oxygen is for breathing, the hydrogen is for rocket fuel, and then a large amount of it is for drinking and watering the plants. So manufacturing, I talked briefly about 3D printing, and China is already printing low-cost houses using 3D printers, so we can print, settlement structures that we're going to live in using 3D printers. That's good. We can print electronic circuit boards. We can't print a whole computer yet. Things like processors are not 3D printable yet, but in 10 years, I'm pretty sure they will be. Did you know that we're already 3D printing bones? So if you break your arm, or your arm is like really crushed in a car accident or something, you can 3D print one exact mirror image of your other one and have it inserted surgically. So organs, maybe in the next few years we won't be relying so much on organ donors, but we'll be able to 3D print organs. This is under research now. So 3D printing is really interesting for Earth and for Mars, because on Mars we're 200 million kilometers away from a shop where we might want to go and buy something. So we're going to really rely on 3D printers to print things that break. Of course, we'll bring spare parts, but at some point your spare part breaks. What do you do then? Turn to the 3D printer. And we've already done 3D printing in the space station. So that's zero gravity, of course. On Mars, we'll have gravity, just less than Earth. So we'll be able to bring along 3D printers. You can even print a 3D printer with a 3D printer. So if you bring along enough 3D printers, you're good to go. So where do we get the stuff to put in the 3D printer? You might ask, are we going to mine the surface of Mars like we've done on Earth? No, we are not. We're going to protect the surface of Mars to be able to do science there. And arguably, mining on Earth is not the most ethical procedure. It causes a lot of damage to the environment. It's not healthy for the people working in the mines. And we're going to have to start thinking about a new way to get resources for the future of Earth. So iridium. Have you heard of it? It's a metal. It's on the periodic table. It's very rare. Touchscreens need iridium. How are we going to get enough iridium and indium, these two metals, to make all of these touchscreens? Because Earth doesn't have a lot of these metals to begin with. Metals like platinum. Earth does have a lot of platinum, but it's very deep under the ground. In South Africa, we extract platinum, and now the mines are, guess how deep? 2 kilometers. 2 kilometers deep to try to get more platinum. So these are all metals that we can find in asteroids. So what is an asteroid? It's a piece of rock that's too small to be called a planet and too big to be ignored. That's what somebody once said. Why can we not ignore these asteroids? Well, because sometimes they smash into our planet. So the impact hazard, that means the danger of getting smashed into by an asteroid, is probably the first reason we should be studying these things. But the other reason is really not for trying to protect anything, but trying to think about future opportunities. Did you know there's a planet 8 times the size of Earth that's half diamond? You might be saying, why am I only hearing about this now? Let's go get it. Well, it's quite far away, 20 light years away. So light takes 20 years to get there. Humans, how long do they take to get there? About 1 million years. So that's why no one's got it yet. But that's just an example to show you there's all sorts of resources in space. And in my opinion, collecting rocks from space I don't find any problem with that. Destroying large parts of Earth to try get at metals that are under the ground, I do have a problem with that. Maybe you agree, maybe you don't agree, but I think extracting resources from space rocks is going to be the future of resources on Earth. And it's actually already even cheaper than it is on Earth. On Earth, it might cost as much as $1,000 for every ounce. In space, it could go as low as $300 per ounce if you get it right, if you have the vision, if you have the belief in your dream. Time is also one of the mysterious phenomena, right? It always goes in one direction. Why? These are the kind of questions physicists ask. Why doesn't it go in both directions? In fact, in quantum physics, it does go in both directions. Electrons can move forwards and backwards in time. Electrons live forever. Humans don't. We go in one direction. How does that happen? So that's a very deep and interesting area of research in physics. But the kind of time I want to talk about now is more like, let's remember just how far we've come in the last few hundred years. So talking about one-way journeys into the unknown, my ancestors were refugees from France, escaping religious persecution in the 1600s. They somehow on foot made their way to the Netherlands and got on this boat and went on a 4-month journey, one way, to Cape Town, into the unknown. There was no Curiosity rover there to send pictures of what they were going to find. They were, out of not so much curiosity, more out of desperation, moving to a new place and staying there. Guess what? I still live in Cape Town. So imagine 1,000 years from now, there could be some Martians showing a picture of SpaceX's rocket. Everyone would laugh at how primitive the technology is and how crazy those people were to have got on that rocket back in 2024, 2026, 2029, we don't know, and made that journey to Mars. Nowadays, we think it's terrifying to make a one-way trip, but if you look back in your family history, each and every one of you have an ancestor somewhere, maybe even your parents, who moved somewhere new and stayed there. That's a one-way trip. So I think that's what humans have been doing. That's why we cover the surface of the planet. Because many people have been explorers. All of us have been curious. All of us have asked questions about what lies beyond that horizon. What can I find if I go there? That's what we do as humans. So going to Mars is really a very exciting, but also very natural thing. It's what we do. We've explored the surface of the Earth. What's next? It's the solar system. And how lucky are we to be living in this time where we're going to explore more of it than ever before. So in conclusion, maybe some of you picture yourself in some kind of craft shooting off into space. Maybe some of you don't. Maybe some of you are very happy staying on the surface of Earth. That's a good thing. But I think what all of us need to very carefully consider and be grateful for is that two of these mysterious resources we have. We have life, right? As amazing and mysterious the phenomenon it may be, we're all alive and we all have time. Some of us more than others, so that's great. That's even better. You've got your life ahead of you. You've got all of this time. These are resources. And what you do with the space in between is really important. It's really important to think carefully about living a life of which you can be proud. I think we need to be proudly human. We need to be proud of where we've come from. We need to be proud of where we're going. Of course, we've made mistakes, but if we don't have a sense of pride when we go about our daily life, whether it be doing schoolwork, doing sport, making friends, hanging out with friends, we need to be proud of what we're doing, because that's the only way, when each and every one of us is contributing in a meaningful, thoughtful and respectful way, that we can create a future of which we can all be proud on Earth and beyond. Thank you very much.